So naming acids. Acids are molecular compounds that form ions when dissolved in water. So they are not ionic compounds, but they do form ions. That can be a little confusing. For Chem 3A, we can always identify acids because they start with hydrogen. When you look at the formula starts with H. If it starts with anything else, it's not an acid. It has to start with H. And we can tell them from their names because their names always have the word acid in them, right? How nice is that? Now, we divide acids into two different groups, and each group has a slightly different way of being named. The first one is called a binary acid, containing only hydrogen and one other element. And then we have the oxyacids, and as this prefix oxy suggests, these acids have oxygen in them. So you can tell which is which because if it has oxygen, it's an oxyacid. If there's no oxygen, it's not an oxyacid. The binary acids we cover first. We've got hydrogen and a nonmetal. And so here's the pattern for the name. We're going to look at the name of that nonmetal. That's the base name here, and we change the ending of the element name to ic. We put a prefix hydro on the front, and then the word acid at the end. So examples here, HCl. This starts with H, it's an acid. There's no oxygen in it, so it's a binary acid, just hydrogen and chlorine. So we take the element named chlorine, and the ending gets changed to chloric. For a binary acid, we put the prefix hydro, hydrochloric acid. This is hydrobromic acid. We know that there's one hydrogen because when these form ions, hydrochloric acid forms the ions H plus and Cl minus. And those two ions together would add to a neutral molecule like ionic compounds would. HBr forms hydrogen ion and bromide ion. Okay? Let's name these two acids. So we look at them. It starts with H, it's an acid. There's no oxygen, it's a binary acid. Of course, we also have this naming binary acids title, floating. There's one of my dog's hairs just like suspended in the air in front of my face. It's very distracting. Sorry. Naming binary acids right there, but HF. So we're going to look at the other element besides hydrogen. That's fluorine, right? Fluorine. There's no flower in fluorine, okay? The common misspelling of fluorine is flourine. See that flour? Fluorine is gluten-free. There's no flour in it. So we change fluorine and we change the ending to ic. And we put the prefix hydro on and we get hydrofluoric acid. Okay? Here's H2SE. Well, what's the name of the element whose symbol is Se? Selenium. Selenium. So we're going to change the ending of that to ic. Selenic. And we're going to put hydro in front and the word acid at the end. Hydroselenic acid.
So it wouldn't be, because there's two hydrogen atoms, so we don't state that.
It's not going to be dihydrogen. That's a really good question. Why isn't it dihydro? Well, let's look at the two ions that this forms when it dissolves in water. One of them is the hydrogen ion, and the other is going to be the selenium ion, or selenide. What would we predict the charge on selenium as an ion to be from the periodic table? -2. It's in the same family as oxygen and sulfur. It's a 2- charge. So if we think about putting ions together to make a neutral compound, that's why we need two hydrogens. You need two hydrogen ions to balance the charge on the selenium ion. Okay? So we don't put di in front of there because it's not necessary. So we're trying to be very streamlined, right, and not write a whole bunch of extra stuff. The goal also is that there is one correct systematic name for every compound. Some of them have other names as well, but there's one correct name. Now, the oxyacids. These have oxygen in them, and when they dissolve in water and form ions, we get an oxyanion being formed. So HNO3, it's an acid, it starts with H, it's got oxygen in it, it's an oxyacid. When that forms an ion, you get the hydrogen ion and the nitrate ion. H2SO3, you get hydrogen ions and sulfite ion. The sulfite ion has a -2 charge, and that's why there's two hydrogens. H2SO4 has a sulfate ion, also has a -2 charge. That's why there's two hydrogen ions. So the number of hydrogen ions in an acid is dictated by the charge on the ion. Okay? So to name these, their names are derived from the name of the oxyanion that is in them. So you look at the oxyanion and say, well, what's the name of that? If it ends with "ite," we're going to change the "ite" ending to "us" and stick the word acid on the end. If it ends with "ate," we're going to change it to "ic," acid. So there's another pairing that you have to remember. "Ite" and "us" go together. "Ic" and "ate" go together. I find stuff like that hard to remember, so I find silly ways of remembering them. So here's a silly sentence. Rick ate him before he could bite us. That's kind of weird, huh? The stranger the better. Rick ate him before he could bite us. And this gives us that relationship between "ite" and "us," "ate" and "ic." Can't spell. So here we have "ite" and "us." Those go together, bless you. And here we have "ic" and "ate." There's another one, the white mouse ate icky cheese. And both of these, I think, are on the, I think they're on the green form. But this will help you to remember what you do with the ending of that name. So here are some common oxyacids, and their names, and their oxyanions, and the formulas, and all that good stuff. So if we look at this top one, HNO2. Well, we cover up the H, and what's in there? NO2. We should recognize that as a relative of nitrate. It's the light version. That's nitrite ion. Nitrite ion is NO2 minus. To name this as an acid, we take nitrite and we change the "ite" to "us and add the word acid, and so we get nitrous acid. HNO3, very similar formula. This has another oxygen though. This contains the nitrate ion. You change "ate" to "ic." So there's nitric acid and there's nitrous acid. They're similar, but they're different. And so that's the pattern that we use for all of these oxyacids. This one, HC2H3O2, looks like a big old mess, doesn't it? And you might wonder, well, why is one of those H's stuck out in front? Why isn't it stuck with the other H's? Why isn't it H4? Only one of those hydrogen ions will come off when it becomes an acid. And you don't need to remember that, but I'm just telling you why we write it that way. There's a reason. So you cover that H up, C2H3O2, that's the acetate ion. Change the "ate" ending to "ic, and you get acetic acid. And thankfully, there's no pronunciation quizzes, so as long as you can read and write these formulas and names, you're good. You don't actually have to pronounce them. Any questions? Let's do a couple of examples. Of course, this first one I sort of already did. So let's just do something else. Let's do H3PO3. So we look at this and we see that the first letter is an H. This is an acid. There's oxygen in it. So what we need to do is we need to cover up the hydrogens, and we see PO3. The 3 hydrogens tells me, if I'm not remembering, that the charge is 3-. We need the name of that ion. What's a good guess? Phosphite is correct. Okay, phosphite, phosphate, those would both be pretty good guesses. You know, when you're doing an exam, if you're not sure of the answer, make a good guess at it. You might get it right. So this is phosphite ion. So we want to change the ite to what? Us. Bite us, right? Rick ate him before he could bite us. So we want to change that to us. So if you just do that, you're going to end up with phosphus. That's way, what? Okay, for sulfur and phosphorus, they have this syllable. Excuse me. So phosphorus and sulfur both have this syllable that kind of comes and goes. So phosphorus, oops. It's Friday afternoon. So the or comes back from phosphorus. Good grief. And so we get phosphorus acid instead of phosphus. Now, that is a little detail that I will not try to trick you on an exam. If this was an exam question, name H3PO3, this, of course, would be one of the correct, this would be the correct answer. That would be one of the choices. I would not put phosphorus acid as one of the correct choices because that's mean. That's a small detail, and I'm not going to trick you with that. I would put phosphoric acid, though, and I would put hydrophosphoric acid because I would try to trick you with those, but not with that syllable coming and going. Okay, so that's phosphorus acid. Notice there's no hydro in front. If it's an oxyacid, you do not put a hydro prefix. Okay, let's do this one, HClO4. Well, if we cover up the hydrogen, what's that oxyanion? It's related to chlorate, perchlorate. So chlorate is ClO3-, that's chlorate. And what we've got here is ClO4-, that's perchlorate. It's got an extra oxygen. Keep forgetting the L. So this ends in 8. What do we change that to? Ic. So this is perchloric acid. Any questions?